Software system design principles make your life a lot easier in future by avoiding rigid software, which is hard to modify, refactor, and test. Selecting and applying right software architecture based on design principles at the beginning of the project lead to better results in terms of efficiency, maintainability, scalability, availability, and reliability. Now, let's go over some important system design principles. Separation of concerns is the most important principle in the software design, as dividing your software system into components. Modularity of application is achieved with separation of concerns. Scalable and maintainable software architecture has decomposed functional blocks with as little overlapping functionality as possible. This approach is the key factor for making software which is easier to understand, develop, maintain, and extend. Different modules can be developed in different programming languages with help of this principle. Inheritance and composition features in object-oriented programming help improve the modularity of applications. Once the separation of concerns is achieved, the common code can be packaged as library and can be reused in multiple projects or modules. When software applications are modularized, it is easy to troubleshoot and fix any bugs and easy to maintain. Since each component is self-contained, dependency issues can be easily mitigated. It is also easy to test each module by mocking other dependencies. Modularization helps in getting more productivity from development teams, as the work can be easily separated among developers or development teams. Modularization abstracts modules from each other. Using abstraction with object-oriented programming languages makes easier to extend the functionality of each module or add new features to existing module without major impact to other modules, as long as the backward compatibility is maintained or new version of APIs are created. New capabilities can be easily added by creating new components or modules. Second principle is achieving highly cohesive and loosely coupled design. If related elements of module belong together and do one dedicated thing, high degree of cohesion is ensured. All related code in a module should be close to each other. This helps in reducing the latency in processing the requests. Coupling refers to the degree to which different modules in an application depends on each other. Each module should be independent of other modules as far as possible, so changes in one system will have minimal to no impact on other components. Inheritance is an example of tight coupling. The composition is an example of loose coupling. Reduced coupling results in increasing cohesion. Event-driven architecture helps applications get notified when interested data item is changed in the backend systems. Application programs listen to these notifications and refresh their cache and take any follow-up actions. If client applications can handle event notifications, it helps in reducing number of calls made to backend systems. Several notification mechanisms are available for use in application development. Some of them are ActiveMQ, RabbitMQ, distributed messaging systems like Kafka. Reducing the amount of processing in the client request path. Significant processing in client request path results in increasing latency in client calls and limits the amount of throughput which application handles. Minimal processing results in quicker response and the application can handle more load with less capacity. Minimal processing can be achieved by pre-calculating the possible response items upfront and cache them in distributed cache. When a client makes a request for a data item, the pre-calculated data can be directly fetched from the populated cache. Using effective cache to make it highly responsive. Use cache wherever applicable to reduce remote service calls, database calls, and amount of processing in request path. This helps in reducing the latency in client calls to service. Use event notification mechanism to keep cache warm and avoid serving stale data to clients. Using asynchronous process. Using asynchronous and parallel processing would help accelerate the client requests and reduce the overall latency. Use frameworks like Refactor for parallel processing of multiple sub-requests involving in a single client request can help. Wherever possible, use asynchronous calls for calling other systems. Reducing the number of calls made in client request path results in better performance of application and make the application is easily scalable. Thank you for listening our broadcast today. Hope to see you again. Bye.